If 2 raised to the power 3 into 3 raised to the power a into b into 7 is the prime factorization of 2520, then find the value of 5a plus 2b. So let's first find the prime factorization of 2520. So we can write 2520 as 2 raised to the power 3 into 3 raised to the power 2 into 5 into 7. According to the question, we are given the prime factorization of 2520 as 2 raised to the power 3 into 3 raised to the power a into b into 7. Comparing this, we get a as 2 and b as 5. Therefore, 5a plus 2b equals 5 times 2 plus 2 times 5, that is 10 plus 10, which is equal to 20. The question is the HCF and LCM of two numbers are 33 and 64 respectively. When the first number is completely divisible by 2, the quotient is 33. Then find the other number. So we know that LCF into LCM is equal to the product of two numbers. Taking the two numbers as A and B, we can say that HCF, which is 33, that multiplied by LCM, which is 264, is equal to A multiplied by B. Now it says when the first number is completely divisible by 2, the quotient is 33. So this means that here A is equal to 2 multiplied by 33. Is because it is completely divisible by 2, leaving quotient as 3. So A comes out to be 2 into 33. Now we can replace A as this. So this is 33 multiplied by 264, replacing A as 2 multiplied by 33, that multiplied by B. So we can further reduce this 33 one times, 33 one times, 2 one times, and cancelling this 2 is going to be 1, 3, 2. So this gives us the value of B, and we get B as 132. Two numbers are in the ratio 21 is to 17. If their HCF is 5, then find the numbers and their sum. Let the two numbers be 21x and 17x, where x is a common factor. We are given that the HCF of the two number is 5, so we can write HCF of 21x and 17x equals 5. Since 21 and 17 are coprime, their HCF is 1, as HCF of two coprime number is always 1. Reason they don't have any other common factor except 1. So the HCF of 21x and 17x is x, as x is a only common factor between 21x and 17x. Therefore, x equals 5. Substituting x as 5 in 21x and 17x, we get the two numbers as 105 and 85. Finally, their sum will be 105 plus 85, that is 190. If a and b are two coprime integers such that a equals 12b, then find the HCF of a and 12. Since a equals 12b, we can express a in terms of b. Further, a and b are coprime, so they have no common factors other than 1. Therefore, the only common factors between a and 12b will be the factors of 12, that is 2, 3, 4, 6, and 12. So the HCF of a and 12 is determined solely by the factors of 12. Thus, the HCF of a and 12 is 12 itself, as a is a multiple of 12. If the HCF and LCM of two integers a and b are x and y respectively, then the value of x square y square over a square b square is. We know that HCF into LCM is equal to product of two numbers. Therefore, HCF into LCM equals a into b. Substituting HCF as x and LCM as y, we can say that x into y equals a into b. Squaring both sides, we can say xy whole square equals ab whole square. So we can say that x square y square is equal to a square b square. That results to give 1. Find the LCM of 2x, 5x and 7x, where x is a positive integer. Factors of 2x is 2nx, factors of 5x is 5nx, and factors of 7 is 7nx. Since x is a common factor and 2, 5 and 7 are coprime, so the LCM of 2x, 5x and 7x is 2 into 5 into 7 into x, that is equal to 70x. Find the LCM of the smallest prime number and the smallest composite number. The smallest prime number is 2 and the smallest odd composite number is 9. Factors of 9 are 1, 3 and 9 and factors of 2 is 1 and 2. Therefore, 2 and 9 are coprime as they share no common factors other than 1. We know that LCM of coprime number is equal to the product of the numbers. Therefore, the LCM of 2 and 9 is 2 into 9, that is 18. If the prime factorization of a natural number n is 2 raised to the power 3 into 3 raised to the power 2 into 5 raised to the power 2 into 7, write the number of consecutive zeros in n. To determine the number of consecutive zeros at the end of a natural number, we need to find the number of times the number can be divided by 10. Since 10 is made up of prime factors of 2 and 5, we need to count the pair of these factors in the prime factorization. In the prime factorization of the natural number, we have 3 factors of 2 and 2 factors of 5. Rearranging this, we get 2 pairs of 5 and 2. So 10 into 10, that is 100. Therefore, the number of consecutive zeros in n is 2.